Hello, my name is Shabsina and welcome to my channel. So in the previous video we have learned about the queue and the types of queue, right? So today we will learn about the data structure tree or the tree data structure. So we rate the linear data structures like an array, linked list, stack and queue in which all the elements are arranged in a sequential manner. The different data structures are used for some different kinds of data. So, some factors are considered for choosing the data structure. What type of data needs to be sorted? It might be I can say that a possibility that a certain data structure can be the best fit for some kind of data. Again, comes to the cost of operations. If we want to minimize the cost of the operation for the most frequently performed operation, for example, we have a simple list on which we have to perform the search operation, then we can create an array in which elements are stored in sorted order to perform the binary search. The binary search works very fast for the simple list as it divides the search space into half. Then finally the memory usage. Sometimes we want a data structure that utilizes less memory. So these are the some factors which are considered for choosing the data structure. So now come to the main part. What is a tree? A tree is also one of the data structures that represent hierarchical data. Suppose we want to show the employees and their positions in the hierarchical from them, it can be represented as in the figure. So this tree shows the organization hierarchy of some company. In the above structure, John, right? This is the CEO of the company, and John has two direct reports named as Steve and Rohan. Right? These are the two direct reports from John. Then Steve has three direct reports named Lee, Bob, Ella, where Steve is the manager, and Bob has two direct reports named Sal and Emma. Right? So this Bob has that Sal and Emma. Right? So Emma has two direct reports named Tom and Raj. Then Tom has one direct report from Bill. So this particular logic structure is known as a tree. Its structure is similar to the real tree, so it is named a tree. In this structure, the root is at the top. This one, John, will be the root node, and its branches are moving in a downward direction, like we see, right? Therefore, we can see that the tree data structure is an efficient way of storing the data in a hierarchical way. Now, let's understand some key points of the tree data structure. A tree data structure is defined as a collection of objects or entities shown as nodes that are linked together to represent or simulate hierarchy. A tree data structure is a non-linear data structure because it does not store in a sequential manner. It is a hierarchical structure as elements in a tree are arranged in multiple levels. In the tree data structure, the topmost node is known as a root node. Each node contains some data, and data can be of any type. In the above tree structure, like we have seen, the node contains the name of the employee. So the type of data would be a string, obviously. Each node contains some data and the link or reference of other nodes that can be called children, right? That these all the nodes are called children because these are some link or references. So some basic terms used in tree data structure are that in this structure each node is labeled with some number, right? So each arrow shown in the above figure, right? Shown in this figure, this above figure is known as a link between the two nodes. First one will be the root node. So what is root node? the root node is the topmost node in the tree hierarchy. In other words, the root node is the one that doesn't have any parents. In the structure, node number 1 is the root node of the tree. In this figure, right? The one will have the root node. If a node is directly linked to some other node, it would be called a parent-child relationship, which means 2 and 3. So now comes the child node. If the node is a descendant of any node, then the node is known as a child node, right? Then comes the parent node. If the node contains any subnode, then that node is said to be parent of that subnode. Then comes the sibling. The nodes that have the same parent are known as siblings, right? So suppose 4, 5, 6 have the same parent 2, which means 4, 5, 6 are the siblings of 2. Then comes the leaf node. The nodes of the tree which doesn't have any child node is called a leaf node. A leaf node is the bottommost node of the tree. There can be any number of leaf nodes present in a general tree. Leaf nodes can also be called external nodes, right? Like 9, 10, 11 are the leaf nodes because they are the bottom nodes of the tree. Now come the internal nodes. A node that has at least one child node known as internal. Then comes the ancestor node. An ancestor of a node is any predecessor node on a path from the root to that node. The root node doesn't have any ancestors. In the tree shown in the above image, nodes 1, 2 and 5 are the ancestors of node 10. So in this is that 1, 2 and 5 are the ancestors, 1, 2 and this 1, 5 are the ancestor of node 10, right? 1, 2, this link and then 10. So these are the ancestors. If we focus in this node, then we will see that the ascendant will be 5, then 2, then 1 in this way, right? 1, 2. Then comes the descendant node. The immediate successor of the given node is known as the descendant of a node. So 10 is the descendant of node 5 because it is the immediate successor, right? The immediate successor of the given node is known as the descendant of a node. So we have all learned some terms which are used in the tree data structure. These are some basic terms, I must say. Then come to the properties of tree data structure. First one is recursive data structure. The tree is also known as the recursive data structure. A tree can be defined as recursively because the distinguished node in a tree data structure is known as a root node. The root node of the tree contains a link to all the nodes of its subtrees. The left subtree is shown in the yellow color in the below figure, and the right subtree is shown in the red color. The left subtree can be further split into subtrees shown in 3 different colors. Recursion means reducing something in a self-similar manner. So this recursive property of the tree data structure is implemented in various applications. So first one is the number of edges. If there are n nodes, then there would n minus 1 edges. Each arrow in the structure represents the link or path. Each node except the root node will have at least one incoming link known as an edge. There would be one link for the parent-child relationship. Then the depth of node X. The depth of node X can be defined as the length of the path from the root to the node X. One edge contributes one Euclid length in the path, so the depth of the node X can also be defined as the number of edges between the root node and the node of X. The root node has 0 depth. Then comes the height of node. The height of node X can be defined as the longest part from the node X to the leaf node. So based on the properties of tree data structures, trees are classified into various categories. First one, the implementation of tree. So the tree data structure can be created by creating the nodes dynamically with the help of the pointers. The tree in the memory can be represented as shown below. So this figure shows the representation of the tree data structure in the memory. In the above structure, the node contains 3 fields. The second field stores the data, the first field stores the address of the left child, and the third field stores the address of the right child, right? So this second field stores the data, the first field shows the address of the left child, and the third field stores the address of the right child, right? So if I one second, if I write a data structure, a programming concept, right? So struct node integer data, okay, then struct node points to the left, point to the left, right, and this one similarly right. So this structure can only be defined for the binary trees, because the binary tree can have at most 2 children and generic trees can have more than 2 children. So this is in programming, the structure of code can be defined in this way, right? So let me minimize it. Yeah. So coming to the applications of trees, storing naturally hierarchical data, which means trees are used to store the data in a hierarchical structure. For example, the file system. The file system stored on the disk drive, the file and folder are in the form of the naturally hierarchical data and stored in the form of trees. Then organized data. It is used to organize data for efficient insertion, deletion and searching. For example, a binary tree has a login time for searching an element. Then comes the tribe. It is a special kind of tree that is used to store the dictionary. It is a fast and efficient way for dynamic spell checking. This one tribe is also new to me when I was first as an engineering student, right? It was also new concept for me when I was writing this PPT. So then comes a heap. It is also a tree data structure implemented using arrays. It is used to implement priority queues. Then comes the B tree and B plus tree. B tree and B plus tree are the tree data structures used to implement indexing in databases. Then comes the routing table. The tree data structure is also used to store the data in routing tables in the routers. So these are some applications of the tree